Don't forget to subscribe and ring that bell.
Good morning. Good morning. It is a beautiful, brisk, cool day up here in the Finger Lake region of New York. And it is also a fantastic day to do some calculus. All right. We are going to continue the 2008 AP Calculus AB practice exam and finish section 1, part A, which covers multiple choice problems number 21 through 28. And oh geez, oh God, oh geez, we don't get a calculator, but that's fine. We got this. Let's start. I love it when the first problem we have gives us either a graph or a table or a chart, because I love them. 21. The graph of f prime, the derivative of the function f, is shown above. And what I like to do anytime they tell me what the graph is, and I see that it's here, but I tell my students that means y, whatever y is, that's the graph value. Okay, if this is the graph of the derivative of f, then the y value is the value of the derivative of f. Okay, so write that down. Okay, and it is shown above. The function f is shown above for x values between 0 and 10 inclusive. The areas of the regions between the graph of f prime and the x-axis are 20. Okay, so let's do this. Highlight. They're 20. Okay, that's right here. They're 6. It's right there. And they are 4 right there. Okay, so those represent our areas. If f of 0 is 2, all right, so f of 0 is 2, okay, what is the maximum value of f on the closed interval from 0 to 10? All right. All right. First of all, maximum value. Let me do this in a different color. We will do this in this orange. Maximum value, okay? In terms of first derivative, what we're given, okay? To find the maximum, I need a positive first derivative. That means it goes up to a critical point where the first derivative is actually 0, okay? To a negative first derivative, okay? So at this point, or at this critical point, I have a maximum value. So I'm going to look at my graph here. And again, I'm going to just look at the y values, okay? Anytime I'm above the x-axis, I have a positive y value. Anytime I'm below the x-axis, I have a negative y value. Keep in mind, when I say positive and negative y value, I also mean positive and negative first derivative, okay? So not only is the y positive here, but the first derivative is positive. Not only is the y negative below, but the first derivative is negative below. So I'm going to go ahead and put some pluses and minuses on this little line here. So all these pluses represent y values on this graph where the y value is positive. Okay, 0 y value, that's an x-intercept. Negative y value, it's another 0. It's an x-intercept. I don't know if I said y-intercept before, but it's an x-intercept. And then positive y values here. I want to go from positive to negative. The only place, okay, here's a critical point, and here's a critical point. This first one right here, this critical point right here, goes from a positive first derivative to a negative, okay? And that's what I want, okay? That's what I want. So at that critical point, this one right here that I'm highlighting, okay? At this critical point, that's a maximum, okay? But they want to know what's that value. All right, well, isn't the value integral? Doesn't integrals give us values? If I integrate from this point where x is 0 to this point, okay, I don't know what it is, and I don't care. But if I integrate this area under the curve, I already know what that is. Okay, it's 20. All right, so if I want my value, I integrate the first derivative graph from 0 to whatever that critical point was, that first one. That should give me 20. That means my y value will be 20. But keep in mind, the answer is not B. Okay, how come? Because yes, my graph went up 20, but it didn't start at 0. It started at a y value of 2. Okay, remember, that's a coordinate. When x is 0, y is 2. So if I start at 2 and I go up another 20, the answer is 22. And that's choice C. A lot more explanation in these problems, but they're simple if you get it. All right, 22, back to basics. If f prime of x equals x minus 2 times x minus 3 squared times x minus 4 cubed, then f has which of the following relative extrema? It either has a maximum at 2, a minimum at 3, or a maximum at 4. And it could be either one or a combination of all of those. I need to do a number line, and I need to see where my critical points are, just like 21. And I need to see where my derivative is going positive to negative, negative to positive. And if you just, if you came right to this problem and didn't see 21, let me reiterate this again. Okay, in order to get a maximum, I need to find out where my first derivative is equal to 0. And I need to have a positive first derivative, which means goes up, to a negative first derivative down. That's a maximum right there, when I go positive to negative. In order to have a minimum, all right, I need my critical point. That's where my first derivative is equal to 0 still, right here. But I need to have a negative first derivative. Then it goes to a positive first derivative. So as I go left to right, I either go positive to negative for a maximum, or I go negative to positive for a minimum. Let's get our number line. We got a number line here. Okay, and the first derivative is above, and we'll put our x values in the bottom. The only places that this can be 0, I'm going to set that equal to 0. X minus 2 times x minus 3 squared times x minus 4 cubed, all right? The only places where this can equal 0 is when I solve each one of those parentheses for 0, meaning x equals 2 would make this parenthesis 0. Okay, so I'm going to put 2 on the number line. All right, so here's where x is 2, my first derivative is 0. Okay, x equals 3 makes this parenthesis 0. So x equals 3. Okay, and x equals 4 makes this parenthesis 0. So I have another 0 at 4. These are where the first derivatives are 0. I need to check the sign, whether they are positive or negative, of my first derivative at points in between and outside of those zeros. So let's pick, I don't know, it's always easy to pick 0. We'll pick 5. And oh my, I got to pick 2.5. And I'll pick 3.5. Okay. Now, what do I want to do with those? I want to put those values, okay, one at a time. I'm going to put them into this, okay, first derivative. Why or how come am I not going to put it in the middle term? Because notice the middle term is squared, okay? This middle term is squared. So it doesn't matter what's in the parentheses here, x minus 3, if it's positive or negative. When I square it, that will always be positive, okay? So every time I'm going to check, okay, I will go do this. I got to take x minus 2. I can take x minus 3 squared, but that will always be positive because I'm squaring it. Then x minus 4 cubed. Now, that will either be positive or negative depending on, x minus 4 being positive or negative. And I'm going to multiply these together. So let's start with 0. 0 minus 2 is negative 2. Okay, I have a positive in the middle. And 0 minus 4 in the end here is negative 4. So if I multiply a negative times a negative, that actually ends up being a positive. So on this side, I've got a positive slope. All right? Let's check 2.5. If I put a 2.5 here, 2.5 minus 2 is a positive 1/2 times, well, this will always be positive. If I put 2.5 here for x, that's negative. Okay, positives times a negative will result in a negative. Negative here. All right. 3.5. So this in purple. Let's go to skinny purple. Okay, I'm going to put a 3.5 here. Minus 2, that's still going to be positive. This will always be positive in the middle, this one. If I put a 3.5 here, that is still negative. So positive times negative, that is still going to give me a negative value. So boom, those are negatives. Let's check the number 5. We'll do it in this fancy little blue here. And again, we want the thinner one. If I put a 5 into this x, that's a positive 3 times, well, this will always be positive, times. If I put a 5 here, that would be a positive 1. If I multiply 3 positive values together, that will indeed give me a positive. So let's figure out what's a minimum and maximum, right? And I'm going to move all this lovely work off to the side here for a second. Let's group this together. Let's minimize this. Just move this off to the side. Okay? So as I look here, my graph is going to do this. It's going to be a positive slope till I hit 2. Then it's going to be a negative slope. I'm going to hit 3. Then I'm going to continue negative till I hit 4. Then I'm going to continue positive. So I have a max at x equals 2. And I have a minimum at x equals 4. Okay, max at 2, minimum at 4. Max at 2. Ooh, it says maximum at 4. Ooh. So out of those things that are given to us, only number 1 is true. Yeah, this should say minimum. It says maximum, so false, false. So only 1. Woo! A lot of explanation. 23. The graph of the even function y equals f of x, it says even function, that's nice, consists of 4 line segments as shown above. Well, in this case, below and to the right. Which of the following statements is false? 4 of these will be true, 1 will be false. Don't circle the first true, you son of a gun. So, let's look at A. If I throw a 0 into this x, okay, that's f of 0. That's this coordinate here. F of 0 is 0. We have a coordinate 0, 0. When x is 0, y is 0. So I get 0 minus, well, f of 0 is 0. That is 0, so that's true. Okay? B. Okay? The numerator is going to be 0. We just did, see this numerator here? That's this thing right here we just did. The top should be 0. Okay? But not so fast, my friend. Don't say, oh, that must be 0. I've still got to throw a 0 into the bottom. Anytime I throw a 0 into the bottom, it should be undefined, not 0. This is false. It should be undefined, not 0. That's false, and your answer should be B. Now, you got your answer. I mean, I can go through these and explain why, but we're kind of running long on time, so I don't. B is false. It's obvious. The rest are true. Okay. So I mean, they tell us it's an even function. All right. So if I factor this stuff out, I can get rid of the x's because f of x. These things are the same in even functions. Okay. It doesn't matter if I negate or not my x value. The output's the same. Okay, so that is actually true. And these are just alternate definitions of derivatives. So they're really just asking for the derivatives. They rarely give you this alternate definition of a derivative. Okay, so even if you were confused with C, D, and E, B should be obvious because you know you got that 0 in the bottom. 24. The radius of a circle, I love these problems, is increasing. Okay, so dr, let's go here. Let's start this. So dr, because we're talking about not the value of the radius, but whether it's increasing or decreasing. So dr is a positive value. It's increasing. So it's greater than 0. At a certain instant, the rate of increase of the area of the circle, dA, I guess we should say with respect to time. You could say this with respect to time, okay, is numerically equal to twice the rate of increase of its circumference, which is dC dt. Okay? What is the radius of the circle at that instant? All right. So, first of all, in order to find dA of a circle, I first need the area of a circle. That's pi r squared. So, dA dt is 2 pi r dr dt. Okay? This is a related rates problem. Anytime I take the derivative of a variable, I need to write d, that variable, over dt. Right? Now let's take a look at the circumference. Okay? The circumference. Circumference is pi times diameter. But let's remember, diameter is 2 times the radius. So I'm only going to say that's pi. In for diameter, I'm going to put 2 times the radius. Okay. So now I'm going to take the derivative of this. Why am I doing that? I want to have, okay, what is the radius? I want to have this r variable in both equations. All right? So let's take the derivative of this. dC dt is, well, it's 2, okay? My pi is constant. The derivative of 2r is just 2, but I need to put dr dt next to it because I took the derivative there. Remember, the derivative of 2x is just 2, right? Well, the derivative of 2r, it's the same thing. It's just 2, but I got to put dr dt next to it. That's what I got this here. Pi is a constant. It'll stay there. So look, here's dA. Here's dC. Keep in mind that dA is numerically equal to twice dC. So, all right, let's go black here. Two pi r dr dt. This is equal to twice dC, which is 2 pi dr dt. Let's just solve for r. All right? So 2 pi r dr dt equals, I'm going to multiply these, 4 pi dr dt. All right, well, look at this. This is great. If I got to solve for r, let me just divide the left side by 2 pi dr dt. What I do to the left side, I need to do to the right side. Boom, boom, boom. I got an r equals. Pi's go bye-bye. Dr dt's go bye-bye. And we have 4 divided by 2, which is 2. This is the value of the radius. It's 2, and that would be choice D. Number 25. If x squared y minus 3x equals y cubed minus 3, then at the point -1, 2, dy dx equals. Oh, so we went right from problem 24, which was related rates, to 25, which is implicit differentiation. We got to take the derivative of everything. And anytime we take the derivative of a y, we need to write dy dx right next to it. So this first one here, I'll color coordinate this. This is a product rule. It's the first times the derivative of the second. Okay, first x squared, derivative of the second, which is y. So that's 1, but it's the derivative of y, so I write dy dx next to it. Minus, okay, the derivative of 3x is just 3, equals, okay, derivative of y cubed. Well, it's 3y squared, but it's the derivative of a y term, so I write dy dx next to it. Okay. This one. The derivative of -3 is 0. So you can put -0 here, but we don't need that. So All right, and it's really, at this point, it's kind of simple. All right, it's kind of simple. 3 3 to what? To x. I did the first. I didn't do times. Look at me go. I'm looking at this. I'm like, this doesn't look right. I did first times the derivative of the second here. Well, that's plus the second times the derivative of the first, which I did not do. So because I get all fancy, boom. I'm looking at that like, that doesn't look right. And you know what? It wasn't. Okay, so we still have, okay, this is still going to be minus 3, so let's put the minus here. So this right here, this first term, here's first times the second, plus the second, which is y, times the derivative of the first, which is 2x. Okay, that's what was missing. Wow, that would have severely made our answer different. All right, so here we go. Let's not go fast. Let's take our time. I need to solve for dy dx. So any place there's a dy dx, I want to get these terms with dy dx on the same side. All right? So, well, let's clean this up. This is going to end up being just 2xy. All right? Let's move this term over to the right side. So let's subtract x squared dy dx. Subtract x squared dy dx. Boom. I have 2xy minus 3 equals 3y squared dy dx minus x squared dy dx. There's a lot of writing. I like to skip a step at this point, but I'm not going to skip a step with you guys because I don't want to hurry and catch another mistake that I make. All right? Let's factor out dy dx. That leaves me 3y squared minus x squared on this side. Okay, still equals 2xy minus 3. Now let's divide both sides by 3y squared minus x squared divided by 3y squared minus x squared. So now I have right here dy dx equals this thing here. But I need a numeric value. And what do I want this at? I want this at the point -1, 2. So I want this at -1, 2, when x is -1 and y is 2. So for every x, I'm going to throw a -1. 2 times -1 times what my y is. This y should be 2. I have minus 3 on the top. Over 3 times whatever y is squared. Again, that's 2. Minus whatever x is squared. -1. All right, let's do some math. This is -4. Okay, -4. I still have a minus 3. All over. 4 times 3 is 12. Minus 1 squared, or -1 squared is 1. -7 over 11? That sounds like a really, really strange answer. But look what choice A is. -7 over 11. Woo. Number 26. For x is greater than 0, f is a function such that the derivative of f of x is the ln of x over x, and the second derivative of x is 1 minus ln of x over x squared. Which of the following is true? Okay, so we got to look at, if you look at all these answers, decreasing, which is first derivative, decreasing, increasing, increasing. So I got to compare the first derivative, all right? But then it also says concave down, concave up, concave down, concave up, concave. So then that's second derivative stuff. So, I'm going to have to figure out these values for the first derivative and second derivative that they give us. So, for example, let's first look at whether f is increasing or decreasing. At 1, okay, see, this is 1. I'm going to start with 1. All right? Well, what is the ln of 1? Okay, the ln of 1 is 0. So what about when it's bigger than 0 or less than 0? All right, so let's take a look at this right here. First of all, first derivative, the ln of 1 over 1, if I put a 1 in for x, that's 0 over 1. That's my critical point. Okay, so let's look at numbers that are bigger than 0. Okay. Well, any number that's bigger than 0. Okay, so we got the ln of x over x. Any number that's bigger than 1, I should say. The ln of 2. That's a positive value. Okay, over 2. So anytime x is bigger than 1, my first derivative will be positive. So it'll be increasing. Okay, first of all, it's not increasing when x is 0. If I put a 0 in for these x's, it will be undefined. It's not e. Okay, it's not that. So now I want an increasing first derivative because my first derivative is positive here. Decreasing for A, no. Decreasing for B, no. So it's either C or D. So these are both increasing. So let's take now a look at, it's either increasing concave down or increasing concave up. Second derivative. 1 minus the ln of x over x squared. Okay, now notice it's saying anytime we're greater than e. Okay, so e is approximately 2.718. I don't want to use e. If I put an e in for here, I get 1 minus 1. The ln of e is 1. I get 0. So that's my point of inflection, e. That's where my second derivative is equal to 0. We want to know a number bigger than e. So let's pick 3. That's a number that's bigger than e. All right? If I put a 3 in for here, the ln of 3, okay, if the ln of 2.718, which is e, if that's 1, a number bigger than that is going to be bigger than 1. I don't know, 1.01. I don't know what it is. It's just bigger than 1. So if I take 1 and I subtract a number bigger than 1, 1.01, whatever it is, and divide that by a positive value. Okay, let's say if they take 3 squared, that's 9. The top is negative divided by 9. I will get a negative, which means I'm concave down. Because my second derivative is negative. So I don't want it concave up. It's not this, D. My answer is choice C. Comparative. You got to compare these. All right, back to a basic problem. Like these problems. 27. If f is the function given by f of x equals the integral from 4 to 2x of the square root of t squared minus t dt, then find f prime of 2. All right, before I find f prime of 2, I should really find f prime of x. Okay, so first of all, if we have f of x, okay, and I want to take the derivative of it, because that's how I get f prime of x. That means I got to take the derivative of what f of x is. F of x is this right here, the integral from 4 to 2x of the square root of t squared minus t dt. Anytime I take the derivative of an integral, they kind of cancel out. The dummy variable goes bye-bye. And what's up here is going to go in place of my t. So it's a square root of 2x squared minus 2x. Use parentheses. Then we need the chain rule times the derivative of whatever this upper limit was. And that happens to be 2x. So the derivative of 2x is 2. This is the derivative of f. And if I want that at 2, well, I just throw a 2 in. The square root of 2 times 2, this whole thing is squared, minus 2 times 2, okay, times 2. That's a lot of 2's. Okay, that's 4 squared minus 4 times 2. This is under a square root. All right? And we got 16 minus 4 times 2. This is still under a square root. It's a square root of 12 times 2. You can't simplify that anymore. I mean, you can. I should say you can. I can simplify this radical and reduce it. But look what, I mean, this is going to end up being 2 times the square root of 12. The square root of 12 is in some of these answers, so don't reduce it. In fact, it's choice E. And that's our answer to 27. Oh, oh, they had to give us one with inverse sign, okay, or arc sign. Okay, I think they tell you in a statement somewhere that sine of -1 is the same as arc sine, and cosine of to the -1 of some value is the same as arc cosine. You need to know your derivative rules. 28. If y equals, I don't know, the inverse sine of 5x, and what's dy dx? Okay, you need to recall that the derivative of the sine of -1 of x is, okay, or you know what, we can call this u. We can call that u. Of u is 1 over the square root of 1 minus whatever u is squared times the derivative of u. Some people like to put the derivative of u in the numerator, meaning they'll just say times u prime up here. And you can do that, that's fine, because u prime times your 1 is u prime. We have sine -1 of 5x. So let's put a 5x in for u right here. So we have the square root of 1 minus 5x, parentheses, please, squared. And then in the numerator is the derivative of this, which is just 5. All right. Why is that important? I have so many students that write it like this. That's the answer. No, I'm not just squaring the x. I'm squaring the whole thing. I'm squaring everything in here, including the 5. That's why the parentheses are important. So if I change this one thing, and I square, okay, the 5 and the x, I get 25x squared. Never try and simplify that radical, okay? And that's the answer. That's choice E. All right. Was pretty painless. A lot of explanation. There was a lot of detail and you know, rigor in knowing the process of some of these things. But the explanation is important for some of you guys that need to see these problems. So that's why I do it, all right? We are done. 32 minutes is not bad. I know previous videos are 10 problems, and this one's like 8 or 9 if you count 21. But they're more detailed. They're more in-depth, these last few problems. We're done with the multiple choice problems where we don't get a calculator. So for the next video, we will get a calculator. So like the video, ring the bell, leave me a comment. And if you follow me, you will get notifications of when I put up those future videos. Have yourself a great rest of your day. Bye-bye.
Don't forget to subscribe and ring that bell.